Okay, finally. Okay, so as I said, what we are going to do today and tomorrow is the review of labor market theory. It's supposed to be reviewed because I usually teach labor economics in the first semester, but since I didn't do it because I was on sabbatical, so it's more of a, probably to a lot of you, it's probably the first time you see this theory. So probably I will spend a little more time. But I just give you only the parts that you need to understand this course. This is not in no way a full description of labor market theory. So if you want a full description, you have to take my course next semester. So what we are going to do today is about the labor supply, and if we have time, probably we don't, but if we have time, we can move on to labor demand, but let's focus on labor supply today. Okay, so theory of labor supply. So if you want, you can look at the labor economics textbook written by Bohars, or actually you can look at any other labor economics textbook, then you will find pretty much the same thing. Okay, so what you are going to do is that, if you think of model of supply of products, right? At the end, you have supply curve, right? So that's what you are going to do today. Basically, you can think of that way. What you are going to do is that we are going to derive labor supply curve. Okay, that's our goal. Okay, now how to derive it? Okay, what we are going to do is that we're going to look at the individual's decisions regarding work. Okay, and from that model, then we can derive labor supply curve. Okay, the model that we are going to use today is called work-leisure choice model. It's simple, okay? Because this individual have a time, okay? And this individual uses time into two things, work or leisure, okay? So actually you can think of work as the time that this person spends to earn money. Leisure is everything else, okay? So this person goes out to work and work for, let's say, 8 hours. Then for 8 hours, this person earns money. So that's work. And for leisure time, this person can do anything, but it doesn't give this person money. Okay, then we call it leisure, whatever it is. Okay? So that's the starting point. So this person has only two uses of time, work and leisure. Okay, leisure. And for this model, we just assume, to make things simple, we assume that there is only one period of life, meaning that this person does not care about the future. So we don't have to worry about the saving, for example. Right? If we have future, then this person should think of how much I should consume today and how much I should consume in the future. But to make things simple, this person doesn't care about the future. So which means this person will spend everything he or she earns, okay? Because there is no point of leaving something behind, leaving something for the future, right? So this person will use everything. So that makes things really simple. And individual's utility. What is this person's objective? Okay, obviously in economics or mostly in real life, the person's objective is to be happy. Okay, and we call it maximizing utility. Using more economic term, we call it maximizing utility. So to be happy as possible. Okay, as much as possible. So what person does is that we call it the maximizing utility. So what affects utility? Utility is affected by two things. One is this person's consumption. Okay? This person should eat or consume something. So this person's utility will increase with consumption and the quite important thing, leisure. Okay? So this person has two uses of time, as I said, work and leisure. Okay? More leisure, this person will get happier. Okay? So what is the downside of having more leisure? This person will have less money because this person will spend less time in work, and less time in work means less money means less consumption. Okay? So there's a trade-off. So working increases earnings, right? The person's income, so which can contribute to increasing consumption, but it will lower the utility by decreasing leisure. Okay? So increasing leisure means happier because this person will spend more time in doing things that this person likes, but will have less money, so we'll have less money on consumption. So obviously there is a trade-off. Okay? The trade-off is the starting point of every economic model. So we have such trade-off. Okay, last assumption is a pretty important one. We assume leisure is a normal good. Okay, leisure is a good. And what kind of good? It's a normal good. What is a normal good? What's the definition of a normal good? Income effect is positive, or in more easier description,
More you have, it's much better for you.
everything is every good. The more, the better is for the good. Right? That's the definition for good. Income effect is positive. Okay, that's true, but that's very technical description. So how do you explain? What does it mean? Income effect is positive. When the person has more income, this person wants more leisure. Okay, that's the normal good. Pretty good, right? Okay. So the opposite of normal good is called what? What's the opposite of normal good? Inferior good, right? Inferior good is you have more income and you want less of it. Then we call it inferior good. Normal good is you have higher income, you want more of it. Then we call it a normal good. Good is the more the better. Then that's a good, right? Okay? This is an important assumption because actually, theoretically, we can assume either way. Leisure is a normal good or an inferior good, actually. We assume it, as you see later, it makes more sense to assume this way. Okay? So let's start from this. Any questions? So if you think about this, it may seem a little complicated assumptions, but if we make it into a certain formula, the things really actually get simpler. Okay, let's see that later. Okay. Now, we said we talked about utility, so let's first look at the individual utility function. Okay, utility function which just generically says that this is just a function of consumption and leisure. Okay. So since we assume that utility increases with consumption and leisure, we can say that this way. So marginal utility of leisure is positive and marginal utility of consumption is positive, which just means that this person has more consumption, happier, more leisure time, happier. That's what it just means. Okay. Now we can draw the indifference curve. Okay. So indifference curve, you should have seen one. Okay. Actually, you should have seen many of them, okay, in let's say principle of economics or microeconomics, okay, and then so in this case, what we are going to draw an indifference curve for consumption and leisure. This is just a totally normal indifference curve of two goods, okay. So it's gonna look like this. Totally normal looking indifference curve. Consumption and leisure. And okay, so we have to, now the thing is, obviously individuals have different preference, which means the individuals have different degree of liking consumption versus leisure. Okay, some person likes like a leisure a lot, some person likes consumption a lot. Okay, that's what you mean by different preferences. Okay? So different preferences is drawn by different shape of indifference curves. Okay? So let's say think of two shapes. Okay, one U1 is steeper and U2 is flatter. Okay? If you look at like just the same point, right? Obviously U2 is flatter. Okay? The question is, which, let's say we call it person 1. So the person who has this indifference curve is person 1. Person who has this indifference curve is person 2. Person 1 and person 2 cannot be identical, right? You know why, right? The same person's indifference curve should not intersect. Okay? So these two indifference curves intersect, which means person 1 and person 2 should be two different persons. Right? If you don't understand why they shouldn't intersect, you should look up textbook of microeconomics. Okay? Now, person 1 and person 2, compare these two individuals. Who likes leisure more in relative terms compared to consumption? 1 or 2? Person 1 or 2? Should be person 1. Why? Why?
Since we want to sacrifice more consumption than person 2, worse than leisure.
Okay, very close. Actually, I think you're right, but using this diagram, you can say this way, right? Think of person 1, for example. Then let's suppose that this person will give up leisure by this amount, A, B, right? So distance between A and B. So this person gives up this amount of leisure, let's say 1 hour of leisure. Okay? And since it's on the, we are using indifference curve, we can ask, if we take 1 hour away from this person's leisure time, then to make this person as happy as before, okay? This person should get more consumption, right? So compensate, okay, the loss of leisure by giving more consumption. Then how much? By how much consumption? That should be BC. Okay? So that's what slope basically means. Okay? We take away AB amount of leisure, then if we give this person BC amount of consumption additionally, then this person will be equally happy. Okay? Now, if we compare it to U2, second person, we can do the same exercise. For example, we take away this person's leisure by TE. Let's say that's the same as AB, so 1 hour. Then this person wants more consumption to be equally happy. That amount is just EF. Okay? So who wants higher compensation? The person 1. The person 1 wants more compensation, which means this person likes leisure more. Okay? So we compare these two individuals. We can say that steeper indifference curve indicates higher degree of preference, okay, for leisure. Simply means that steeper indifference curve just means that this person likes leisure a lot than the person who has flatter indifference curve. Okay? That comes handy later. So stronger taste for leisure, okay, this just means this person likes leisure a lot, which just means that steeper indifference curves. Or we can say greater MRS or slope is greater. Okay, that's basically the same thing. Okay, so the other way is a stronger taste for consumption. Actually, there are only two goods. So Stronger taste for leisure basically means weaker taste for consumption, and weaker taste for leisure, it just means stronger taste for consumption. Stronger taste for consumption is flatter indifference curves. Okay? So if it becomes steeper, this person likes leisure more. If it becomes flatter, this person likes consumption more. Okay? Okay, so that's the utility part. And we are going to maximize this person's utility given this person's budget constraint. Okay? So it's just the same exercise, like two good utility maximization with two goods. Basically the same thing. We just have two goods, right? One is called consumption. The other one is called leisure. Leisure is different from, let's say, apple or bananas or something, because this is time. Okay, but in essence, it's just a good. Okay, so budget constraint here we're gonna use. Okay, so we have to introduce time, so later we will do it. First, we have to think of this person's earnings, okay, income. Income comes from work. Okay, so to indicate that part, we think of hourly wage rate. So how much this person earns for each hour of work. We just call it W dollars. Okay? Can be $10, $5, whatever. Okay? And we have to assume that the number of hours this person can spend on work and leisure should be fixed. Total number should be fixed. Okay? For example, we have only 24 hours a day, right? So each person has the same total number of hours. Okay? So think of if you think of one day, it's gonna be, 24 hours. Or if you think of 1 week, 24 times 7 or whatever. So we just, if you assume the unit, okay, we can just figure out T. T is just given by the universe. Okay, it's just a physical law. It's not economics. It's just a physical law which gives us T. Okay, and then T is gonna be divided into two things we assumed. One is working. We just number of working hours. We use H for it. And then leisure hours, we just use it L. Okay, L we use capital letter, but uppercase. But no, I don't know why. But it doesn't matter. Okay, so T equals H plus L. Okay. Because, lowercase l looks like 1, so it's better to use uppercase. Okay, so this is by the first assumption, T must be equal to H plus L. And consumption, which is C, and non-labor income, we assume this person may have non-labor income. So income this person gets without any work. For example, if this person has, let's say, some assets, let's say V is something like returns from the assets. So this person gets this money regardless of working or not. Okay? Okay, get it? Pretty simple idea. Now let's write down the budget constraint. Basically, the budget constraint first part. Okay, since we assume no saving, we just said, this person's consumption should be equal to the income. Income has two parts. One part coming from work, the other part coming from not work. Okay? So the coming from work, we call it earnings. Okay? In English, if earnings means, something you get from working, that's earnings. Income is just a general term. Earnings is from work plus non-labor income. Now, what is consumption? Consumption is obviously we can write C, okay? So total amount of consumption, C, equals, what is earnings? Earnings is hourly wage rate times hours of work. Plus V, it's just non-labor income. Okay, simple. All right. Here, actually, we did not specify price for the consumption good because we assume that, everything is divided by P, okay? You can think of it as like real terms. W is a real wage, Okay, V is a real non-labor income. Okay, actually, do I have that later? Okay, C, so that's what I said. We may write C equals PC, right? P is the unit price of the consumption good, and C is the amount of goods consumed. Or just think of C as like amount money that this person spends on consumption. Okay, that's better. Okay, C is the dollar amount this person spends on consumption. WH is the dollar amount of earnings. V is the dollar amount non-labor income. Now, since H is just equal to T minus L, right? So you can write this way again. Okay, this one is easier than this one because in our diagram, indifference curve, we have C and L, not C and H. So writing things down using C and L is easier, okay, than using H. Actually, it's the same, but anyway. Okay, so this is basically the same thing. Now, this one can be written in this way as well. Okay, so C, this is just the algebraic manipulation. Minus WL, we just goes to the other side and becomes C plus WL equals WT plus V. Okay, and we call WT plus V YF, full income, potential full income, which means if this person works all the time, no leisure whatsoever, then WT plus V is this person's maximum income this person can get. Okay? So that's why we call it potential full income. Potentially this person can get up to WT plus V. Okay. And this income, we call it just YF. Okay. We interpret this equation this way. This person has full income, and this person can spend that money into two things, two goods. One is C and one is L. Okay? If you think of, for example, like a normal two-good utility function, right? Then we usually have like two goods like X and Y, right? Then what the budget constraint generally looks like something like income should be like Px times X, right? Plus Py times Y. Okay? That's what you usually see in the two good consumption model. Okay? So income is spent on buying good X and buying good Y. The same thing actually. YF is spent on buying two goods. One is C. Actually, we have like PC, but just we can. Okay, let's say PC plus WL. Okay, P is we just forget about P, but anyway. So P is the price of the consumption good, and W is what? If you look at this way, W is price of what? Leisure. Okay. So one way to think about it is if you look at this way, W is the source of income. If you work 8 hours, then for each hour you get W. In this case, W is actually a price of leisure, which means if you spend 1 hour on leisure time, you will lose income of W dollars. Okay? So that's the price. That's the price you pay. Okay? Let's say my hourly wage rate is $10. Then you can say if I work for 1 hour, I earn $10. Or you can say if I spend 1 hour on my leisure, I will lose $10. Basically the same thing, right? So two sides of the same coin. Okay. So W is, you can say it's wage rate, or you can say it's a price of leisure. Okay? It's basically the same thing. Get it? So this is the way, basically, we just, this is the same structure of this budget constraint. Okay? But here we use YF, okay? Hypothetical potential full income. Okay? Questions?
Will you never work on the small p?
Small p. Small p, you mean this one? Yeah, actually we use C only, but actually I was kind of sloppy. C is actually, you can think of PC, price times the price of a consumption good, and C is the amount of consumption goods you consume. So that's P times C. But we just use C to whole thing, PC. Okay? So here we have PC. So I wrote down that in the next line. Okay? Because in the labor economics class, we concentrate on wage, not the price of a consumption good. So we just don't care much about price of a consumption good. That's why we didn't write P much. Okay? Kind of forget about P. Just look at W only. Okay? Well, if you want, you can write it this way. Okay? Doesn't matter. Okay? Get that? Now, so we can understand that how things work, because we can write budget constraint now this way. So LC, and we just, first thing is that L, okay, first thing is that in all cases of worker leisure choice model, horizontal axis always gives you leisure time. Vertical axis always give you consumption. Okay, so this is like a firmly established convention in economics. L always gets the horizontal axis. Okay, with L means, so if you move from left to the right, leisure increases. Okay, if you move from right to left, working hour increases. Okay. So if you want to count the number of leisure hours, you do it from left to the right. You want to count the number of working hours, you do it from right to left. Okay? So let's write it this way. Now, since we assume that total hour is given by T, so leisure cannot be more than T. If this person doesn't work at all, this person's leisure will be T. So T is maximum of leisure hour. Okay? And first, let's assume non-labor income. Think of non-labor income. Non-labor income is the income this person gets without any work. Okay? So if this person gets leisure hour of T, still this person will get V. Okay? So that's how we indicate that this distance, vertical distance, okay, between at point T, this person will get V dollars. Okay, that's what it simply means. And then if this person has 0 hour of leisure, okay, so work all the time, this person will get income of WT plus V, full income. Okay, so this is that part. So obviously this person normally will get in between, right? So from 0 hours, this person, if this person gets 1 additional hour of leisure, this person's consumption should fall by W dollars. Okay, so that's how, that's what this line indicates. Okay, this person has more and more hour of leisure, consumption falls for each hour of leisure by W dollars. That means the slope is W, minus W actually. Okay, So if you write an equation for this line, it's just simply C equals minus WL plus V plus WT. So minus W is the slope, V plus WT is intercept. Okay? So it's just a line of an equation. Equation of a budget line. Okay? Which is, the important thing is that you should realize that the slope is W. Okay? So if the wage rate is high, then the line should be steeper. If the wage rate is lower, then line should be flatter. Okay? Okay, get it? Now think of maximization of utility. Okay, it's a pretty much, just the same model as I said, the two goods. Okay, so the maximizing should be the same thing. We have a budget line, budget constraint, and this person will maximize utility on the budget line. Okay, within the budget constraint, which pretty means that basically means on the budget line. Okay, so U0 point A is not maximizing because this person can move from A to P, for example. This person's indifference curve will be located on higher plane, which means higher utility. U1, I think. This one looks good, but it's not possible because this is just beyond the budget constraint. This person cannot get to that point. So the best this person can do is obviously the point P. Okay? So basically it's the same as this two goods utility maximization model, right? Okay. So what's special about P? The special thing about P is the slope of the indifference curve is equal to the slope of the budget line. Okay, slope of indifference curve is MRS, marginal rate of substitution, or it's a marginal utility of leisure divided by marginal utility of consumption equals the slope of the budget line, which is W. Okay? It's the same, right? Slope of the indifference curve should be equal to the slope of the budget line. It's the same principle for two goods model. So basically we use the same principle here. Okay? Questions? Okay, so in this case, this person, this is 1 week. So 110 is this person's maximum number of hours, which is lower than obviously 24 times 7. Okay. Assuming that you can assume like if this person should spend time for, let's say, sleeping and eating, right? So those kind we just exclude them. Okay, it doesn't matter actually how you do it for this one. But anyway, so this person gets 70 hours of leisure, and working hours should be from right to the left. So that's 40. So total number of hours 110 minus 70 should be 40. Okay. So we figure out number of leisure hours, then automatically we figure out number of working hours. Okay, so in this model, there is basically deciding on leisure, that means deciding on work. Okay, the same thing. So anything that increases, let's say, leisure hour will decrease work. Anything that decreases leisure hour will increase work. Okay. Now, let's think of this one now, the interesting part. Let's see how the individuals respond when the budget constraint changes. Okay. First, what happens if the non-labor income increases, for example? How can it increase? Okay, in numerous ways. For example, like this person, let's say, rate of return for this person's assets, let's say, will increase. Or let's say this person gets some transfer from, let's say, private or public source. Let's say this person may get transferred from, let's say, their relatives. This person had an uncle, okay, missing uncle, which turns out to be, billionaire. And he dies, and he writes a will that, okay, I give everything I have to you. Okay? So you have what? It's windfall of V, for example. Or the government may decide one day that probably we have to give some money to our people. Okay? It turns out that they have just money lying around next to the Bank of Korea, and then, okay, let's just give out the money. Okay, then everybody gets some money. Then that's what? Non-labor income. Doesn't matter whether you work or not, you get non-labor income. Okay, what happens? What happens here is that it's important to see that what part changes. First thing is that the slope, does it change or not? It shouldn't change. Okay, what happens is that your dead uncle gave you $1 billion. That's a lot. Okay, but anyway. So what happens? Only thing that happens is V0 will change. For example, V0 to V. Okay. So before your dead uncle shows up, your dead uncle's will shows up, you were happy at point D. Okay? Now your dead uncle's will shows up and you get $1 billion. Your non-labor income changes from V0 to V1. Okay? So this is $1 billion. So you had $1 billion in your pocket. Now you have $2 billion. Okay? Now it increased from V0 to V1. Okay? What happens to budget constraints? Just the whole thing will just shift up. Right? So the slope doesn't change. Just the vertical distance changes. Just it shifts up. So everything is parallel to the previous one. Just shifts up. Now, point D is obviously not the optimal point anymore. Okay? What happens? This person will find the new optimal point that should be point E. Okay? So at point E, this person's leisure hour will increase from L0 to L1. Or we can say this person's working hour will decrease from L0T to L1T. Okay? Get it? How do we know that this person's leisure hour will increase? Because we assumed leisure is a normal good, right? That's what exactly that assumption means. You have higher income, everything else is equal, you just have higher income. Since leisure is normal good, you want more leisure. Okay, that's how this assumption works at this point. Is this a good assumption? Think about it. Your dead uncle gives you $1 billion. Will you work more? Now I have $1 billion, I should work even more. Or you would say, like I would do, $1 billion, I quit this job and travel around the world in luxury, and no work in my whole life ever again. Okay, that's what I would do. If I have $1 billion, I will quit and I will disappear. Okay, to whatever place that you will never find me. Anyway, which is a better assumption, more work or less work? Less work seems to be obviously the better assumption. That's why we assume leisure is normal good. As I said, theoretically, you can assume either way, actually. It doesn't, even if you assume leisure is inferior good, we can have a perfectly good model. But the model will not reflect, the normal situation that people actually would act. Okay? So that's why we assume leisure is normal good, because it seems to be obviously the better assumption. Okay, so one thing we just figured out, Higher income, higher non-labor income leads to less work. Okay? This is actually very important insight if we look at, for example, how the welfare program works. Let's say cash transfer from the government. It increases. This model says if the government gives you more cash transfer, then the individuals are less likely to work less. Okay? That's how we are going to use. Okay? Not the $1 billion fantasy. What we are going to use is that we're going to use it to explain what happens if, let's say, cash transfer program changes. Okay? Now let's change the wage rate. Okay, this one is a little more complicated. Okay, why? Because, as I said, this W has dual meaning. One is wage rate, how much you earn for each work, or how much you pay for each leisure hour. Okay? So, because of this, wage rate thing is a little complicated. How? Okay, think about it. Let's say wage rate goes up. If the wage rate goes up, that means your income going to be higher because your wage rate is higher. Let's say your wage rate was $10 per hour. Now let's say it becomes $12 per hour, which means what? You will earn 20% more, okay, for each hour of work. Let's say if you're working for 8 hours, your income was $80. Now it's $96. Obviously, you have a higher income. Now you have a higher income. How about your leisure hour? It should increase or decrease? Higher income. So your leisure hour should decrease or increase? Leisure is normal good, right? So leisure hour should increase, right? So you have a higher income. Naturally, okay, I should spend more time on leisure. Okay, that's one part. Okay? So higher income for given work hours, consume more goods, and enjoy more leisure. Okay? That's one thing that can happen. So as I said, for example, like you have $10, so you worked for 8 hours. Now $12, you may work for 7 hours only. Okay? That's possible. Okay? Now since I can earn much more, probably I should cut down my work hour. Okay, and enjoy more leisure time. Okay? Okay, that's good. So we think of this route, which basically means wage rate goes up, then we have higher demand for leisure, which simply means we want more leisure. Higher demand for leisure basically means less work. Okay? Or lower labor supply. So that's the example I gave you, right? $8, $10 per hour. I work for 8 hours. Now $12 per hour. Probably I should work only for 7 hours. Still, I have enough money. So I just work 1 hour less. But there is the other side. What is the other side? The other side is that now leisure becomes actually more expensive. Right? So it's a price of leisure. Okay, if I skipped 1 hour work, I lost $10. I used to lose $10. Now I use $12. That means what? I would be more reluctant to skip working. Because $10, okay, that's nothing. But $12, that's a lot. I don't want $12. Okay? So, because the price of leisure goes up. Okay, that's how we write it in economics. So leisure becomes more expensive relative to goods. So we consume less leisure, and then we consume more goods. Okay? So the way of thinking is this. Okay, I used to get $10 per hour. So I worked for $10. $10 $10 per hour. So I used to work for 8 hours. Now it becomes $12. I figures out, okay, I used to have, let's say, 10 hours of leisure. So I lost, in a sense, $80, $100. Okay. Now if I still use $10, 10 hours for my leisure time, I lose now $120. That's a lot. Okay. So if I think about it, okay, I should work more. Okay, because leisure is such an expensive thing to enjoy now. It was $10, now it's $12. So it's such an expensive thing. So I probably have to take down my leisure time, and then probably I should earn more and then use that money to buy things, buy an iPhone. Okay? I used to have like an old Samsung Galaxy phone that exploded. So then, okay, I realized, okay, I have more money. So what I should do is that since my time is more precious, I should do more work and earn more money and spend it to buy something else. Okay, get it? So there are two ways of thinking. One way is that since I can earn a lot with less work, probably I should cut down the work. Or the other way of thinking is that I lose so much money now. If I do not work, I should work more. So there are two conflicting ideas. So this one is lower demand for leisure, so more work. So two sides. So there are two sides. This side we call it income effect, okay, for obvious reason. This side we call it substitution effect because this one makes the substitution goods for leisure possible. Okay, get it? So when the wage rate changes, there are two forces. Okay, one is wage rate goes up, which means higher income. Higher income means more leisure because leisure is normal good, which means less work. Higher wages means higher price of leisure. So since leisure is expensive, we consume less leisure, demand less leisure, so more work. Okay? So both cases are possible. At the end, basically, what happens will be determined by which side wins. Okay? For some person, income effect side wins. For some people, substitution effect side wins. Okay? So theoretically, we can say that it's ambiguous. We cannot say exactly what's going to happen. Okay? A lot of people think the wage rate goes up, then you would work more, but surprisingly, okay, if you do actual studies, it's not that clear. Okay, wage falls, basically the opposite thing happens. Wage rate goes up, goes down, then income is lower, so what? Demand for leisure should increase or decrease. Income is lower, so demand for leisure should decrease, right? Because you have less income, so you demand less leisure. So that means what? More work. Now wage rate falls, then price of leisure is cheaper, right? Leisure becomes cheaper. If I skip 1 hour of work, I used to lose $10, now lose only, let's say, $7. Oh, okay, let's skip work today. Okay? Because it's nothing. So what? Leisure becomes cheaper, so more demand for leisure, which means less work. Okay? So that call it substitution effect. Okay? So if we just summarize here, income effect part, increase in the wage rate, decreases hours of work. Decrease in the wage rate increases hours of work. Okay. So more income, less work. Less income, more work. Okay. So that's the income effect part. Substitution effect part, increase the wage rate increases hours of work. Decrease in the wage rate decreases hours of work. Okay? So think of the direction. Income effect part, direction of wage rate change and direction of hours of work, it's opposite. Okay? Wage goes up, labor, hours of work falls. Substitution effect part, the same direction. Wage goes up, hours of work increases. Okay? So you have to remember that one. So total effect depends on which effect dominates. If the income effect dominates the substitution effect, then hours of work will change in opposite direction to the change of wage rate. If substitution effect dominates income effect, hours of work will change the same direction as the change of wage rate. Okay, graphically, actually this substitution effect and income effect, you should have seen it in let's say, Toogood's model. We have substitution effect and income effect. But here we have a little more interesting thing. Now let's say assume that wage goes up from W0 to W1. So what changes here is the slope. Okay? So V doesn't change, only the slope change. So wage goes up, so the slope becomes steeper. Now D is not the optimum anymore, obviously. So it changes from, let's say, point D to point E. Okay? D to E. So when you look at this, leisure hour changes from L0 to L2. So leisure hour decreased, right? So which effect dominates? Well, labor supply. Think of labor supply. Labor supply increased, right? Which effect dominates? Should it be? By income effect. Think of it. Income effect, wage goes up. Then since income is higher, demand for leisure goes up. So it should be less work, right? That's the income effect part. Substitution effect part. Wage goes up, price of leisure increases, so less leisure, so more work. That's substitution effect part, right? So in this case, which effect dominates? Should be substitution effect. Okay. Graphically, we can show there are obviously more than one ways to show income and substitution effect, but in our case, we use this particular way of doing it. What we do here is that we assume hypothetically wage rate didn't change, but only, let's say, non-labor income has changed in a way to make this person attain the utility level of U1. Okay, so hypothetical change in the non-labor income. So we assume hypothetically, it's all hypothetical. It's not real change. So hypothetical change here is that only non-labor income increased actually, but wage rate didn't change. If we do it, then if that happened, hypothetically this person will move from point D to point D prime. Okay? So that part gonna show up from moving from L0 to L1. Okay? So this change is due to what effect? Income effect. So as you can see, by income effect, leisure hour will increase. From D prime E, we say basically that this person's income didn't change, only wage rate changed. The price of leisure changed. So that part we call it what effect? Substitution effect. Okay? So here the substitution effect is greater than the income effect. Actually, there are different ways of drawing this diagram. If you know like a Hicksian or what is the other one? There is the other one. Yeah, Slutsky one. But in this case, actually it didn't matter at the end. Okay? But in our particular case, and in labor economics, this is the convention to draw this way, sufficient and income effect. Okay? What we do is that, basically what we do is that we draw a hypothetical budget line that is parallel to the old budget line, but touches the new indifference curve. Okay? So we show the income effect first, okay, by this way. And then the rest, we call it the sufficient effect. Okay? So obviously here the sufficient effect is bigger than the income effect. Income and sufficient effect will come handy later when we talk about cash transfer programs or other social insurance programs. But we will figure out later that part. You have to know these basics. Now, obviously, we can draw a case where the income effect dominates the sufficient effect. Okay? So in this case, wage goes up, then moving from P to Q. Okay? No, P to R. P to R. Moving from P to R. Okay? So leisure hour increased. What is the income effect? We draw a budget line, hypothetical DD, parallel to the old one, FE, EF, okay? But touches a new one that is point Q. So moving from P to Q is what effect? Income effect. And Q to R is sufficient effect. And obviously income effect is greater than the sufficient effect. Then at the end, leisure hour will increase. Okay? So if the sufficient effect dominates the income effect, okay, then wage rate goes up, then labor supply will increase. Wage rate goes down, labor supply will decrease. If income effect dominates sufficient effect, wage goes up, labor supply will decrease, okay, and wage goes down, labor supply will increase. Okay? Okay, I think we should stop here today, and then we're gonna continue tomorrow.